What if the farm we desperately need isn't a field at all, but a marsh? There's a common wetland plant, so ordinary that we call it a weed, that can produce food in 4 different seasons, filter polluted water, store carbon, and yield more usable starch per acre than a cornfield. That same abundance, the way it escapes privatization and refuses to fit into the planted row logic of industrial agriculture, is exactly why it was pushed out of the modern landscape. If that sounds radical, stay with us. Archaeology and contemporary science both have chapters to read, and the story bends from ancient kitchens to 19th century law books and 20th century drainage machines. Archaeological evidence shows people have been eating this plant for a very long time. Starch residues on stone tools found in river valleys in what's now China, and similar residues in sites across Italy, indicate that prehistoric people harvested and processed wetland plants tens of thousands of years ago. According to the source cited in this investigation, those starch traces link back to a perennial wetland species that, long before we sowed the first grain fields, functioned as a dependable pantry. In other words, humans were coaxing food from marshes long before rows of annuals defined agriculture. To understand why this plant mattered, picture a year in a marsh rather than a year in a field. In spring, slender, pale green shoots push up from the water. People biting into them describe a fresh snap, a flavor somewhere between cucumber and asparagus. Early summer brings compact young flower heads that, when roasted or boiled, offer a texture and sweetness some compare to corn on the cob. Later, in midsummer, clouds of golden pollen fall like dust. When collected and dried, that pollen can be ground into a flour, an unexpectedly protein-rich, fine powder that mixes into porridge and breads. Finally, after the first deep frosts, the roots, rhizomes, are dug. They are dense, starchy, and when processed into flour can be stored for long periods. That 4-season cycle, shoots, flower heads, pollen, rhizomes, turns a single patch of marsh into a year-round source of calories and nutrients. Beyond food, the plant served as infrastructure. Its leaves were woven into mats and walls, its fibers twisted into cordage, its fluff stuffed into bedding and insulation. Indigenous communities across continents used it to roof huts, to wrap and store food, to make medicines and temporary flotation devices. These uses turned marshes into living technology, food, shelter, and tools all emerging from the same place. Some specific tribal names mentioned in older accounts of use are uncertain in the primary transcript, and therefore listed as indefinito in the sources. What remains clear is the pattern. Diverse peoples developed deep, practical knowledge of marsh plants, integrating them into daily life in ways that modern shorthand tends to forget.
So how did a perennial pantry become a wasteland in our cultural imagination? The turning point was political and technological. In the 19th century, as settler societies expanded, wetlands were often declared waste ground, land to be reclaimed for productive use. In the United States, legislation like the Swampland Act transferred millions of acres of wetlands from public domain to state and private hands with the explicit aim of draining and converting them. Engineers and inventors responded. Steam-powered ditching racines and other mechanized drainage technologies made it possible to take water out of landscapes at industrial scale. Wetlands that had been seasonally productive, that had stored carbon and filtered water, were plowed under and planted with annual crops, corn among them, because the logic of private property rewarded seeds you could sell, harvest cycles you could control, and fields you could finance. This was not just about short-term productivity, it was about an economic model that favored scarcity you could own. Perennial marsh systems produce continuously and reseed themselves. That continuity made them hard to enclose and monetize in the same way corn or wheat could be. When a plant's value is in its ongoing abundance rather than in a packaged, patented product, the incentives to convert that landscape to an annual commodity system become powerful. Over time, we replaced patches of living infrastructure with rows costing more and more inputs. Those inputs come with consequences. Annual monocultures require tilling, repeated planting, synthetic fertilizers, and pesticides. Fertilizer applied to fields often runs off into rivers and washes downstream into lakes and estuaries, fueling algal blooms that suck oxygen from water and kill fish. Soil that once stayed in place beneath perennial roots is now vulnerable to erosion. Carbon that had been stored in organic rich wetland soils oxidizes and escapes as greenhouse gas once drained and exposed. According to the source documents in this investigation, vast acreages were drained. Numbers are given in historical accounts and should be verified independently, but the pattern is clear: a transformation of landscapes at continental scale with deep environmental costs. At the same time, some of the same modern science that cataloged those costs has begun to reevaluate what marsh plants can do for us. Recent field research cited in contemporary studies shows high biomass yields in wetland stands, Again, numbers quoted in the source suggest very large per acre figures for both edible starch and overall biomass, but we present them here as according to the source pending independent verification. What matters less than a single number is the functional picture. These plants capture nutrients out of water, removing excess nitrogen and phosphorus that would otherwise feed harmful algal blooms. They accumulate organic matter in their roots and soils, acting as carbon sinks.
Their dense growth can be harvested periodically, and experiments demonstrate that ash or composted residues from that harvest can be returned to adjacent lands as a nutrient source, creating a form of closed-loop fertilization that reduces dependence on externally produced chemical fertilizers. Practical pilot projects underscore the potential. Institutional harvests and managed wetland restorations, including work in places like Manitoba and research trials in Minnesota, have explored regular cutting regimes, pollen collection, and processing techniques. In some cases, institutions have experimented with harvesting biomass for animal feed or for converting into more stable food products. Researchers also experimented with phytoremediation, using these plants to clean water, finding measurable reductions in phosphorus and nitrogen after water passed through managed marshes. These are not silver bullets. They are examples of how perennial wetland systems can be designed to deliver multiple services: food, nutrient recycling, water purification, and carbon storage. Why then, if the benefits are so rich, was this plant marginalized instead of integrated into our agricultural system? It comes back to incentives and the structure of ownership. Crops that fit neatly into a market, seed companies selling patented hybrids, banks underwriting a planting season, commodity markets trading futures, align with industrial agriculture's architecture. A plant that regenerates itself, that spreads across water and resists easy fencing, challenges the bookkeeping that makes land profitable under that model. Moreover, wetlands were politically categorized as nuisances, disease, mosquitoes, and impediments to development, narratives that justified drainage and conversion. It's not that individuals sat down and conspired to erase a food system. Rather, a combination of laws, technology, and market incentives bent the landscape toward annuals, and the parts that didn't pay in the expected ways were labeled expendable. There are further objections worth addressing. We cannot and will not claim that this marsh plant is an instant universal replacement for staple crops like corn. Climatic limits, processing needs, labor considerations, and cultural preferences all shape what scales realistically. The goal here is recognition, to acknowledge that a perennial, seasonally diverse plant once played a crucial role in human diets and landscapes, to consider that its ecosystem services are valuable in an age of nutrient pollution and climate instability, and to explore how managed marsh systems might complement, not replace, existing agriculture. If we imagine pathways forward, they look like plural experiments rather than one prescription.
Restoring patches of wetlands along waterways, investing in processing technologies to turn pollen and rhizome starch into shelf-stable products, incorporating harvested marsh biomass into regional nutrient budgets as a recycled fertilizer, and supporting community-led management that respects traditional ecological knowledge are all pieces of a mosaic. Pilot projects, cooperative harvesting schemes, and water quality programs that pay farmers and landowners for filtration services could create incentives that align restoration with livelihoods. Importantly, these are proposals for research, policy pilots, and local initiatives, not a carte blanche to assume immediate wide-scale substitution. There's also a moral and cultural element to reckon with. Calling wetlands waste erased knowledge systems and practical technologies that kept communities fed and sheltered for millennia. Restoring recognition means learning from those systems without romanticizing the past. It means engaging with indigenous knowledge respectfully, honoring practices that persisted and survive today, while designing modern institutions that make living marsh economies viable within contemporary legal and market structures. Where the transcript contains unclear names or ambiguous attributions, those are recorded as indefinito, pending careful verification. This is not a distraction, but an obligation to accuracy when dealing with human histories. So what does this all amount to? We traded a kind of perennial abundance, harder to enclose, harder to monetize, for a system that yields immediate standardized commodities and concentrates profit in certain nodes of the supply chain. That trade brought scale and certainty for some actors, but it also offloaded costs onto rivers, soils, and future climate stability. The plant that survived our drainage ditches and roadside wetlands is not merely resilient, it also points to different ways of organizing food production, ways that emphasize multifunctional landscapes, nutrient cycling, and living infrastructure. We don't offer a single technical fix. What we are asking for is recognition, to stop seeing some marshes as waste and begin treating them as potential assets.
Imagine managing a network of small, strategically restored wetlands that capture runoff from fields, polish water, provide seasonal food and fiber, and sequester carbon. Imagine municipalities paying for those services instead of building more treatment plants. Imagine local processors that convert pollen and rhizome starch into specialty products that add value to regional economies. None of this erases corn or the importance of staple grains, but it does expand the palette of tools available to farmers, communities, and policymakers trying to navigate a warming, nutrient-saturated world.
We began with a simple provocation. This plant yields more food per acre than corn, and because it refuses to be contained by the market logics that govern modern agriculture, it was treated as a threat. That framing is meant to jar us into looking at policy and incentives, not to accuse individuals. The solution is not to blame, but to redesign institutions so that multifunctional ecosystems are an asset rather than an obstacle. If this reframing struck a chord, subscribe for more deep dives into the hidden infrastructures of our food system. Share this with someone who walks past a ditch every day and never wondered if it could be a pantry. And when you next drive by a marsh, try imagining not a nuisance, but a living technology. Seasonal food, water filtration, carbon storage, waiting for policies and communities willing to see it for what it has always been.